Hello, this is Nas Babar from NB Network Lessons. Hope you guys are doing okay. My today's topic, I'm really excited about it. It's about circuit analysis, electric circuit analysis. As you know that I am an electrical engineer myself. I graduated in 1990 from a university in Alabama, and I have passion for electrical engineering and circuit analysis and so forth. And I wanted to share knowledge with you, as as one person to another person. I'm sharing knowledge with you, and I dedicate this lecture to my father, who was also an electrical engineer, and he influenced me a lot to become an electrical engineer. So without any further ado, let's go ahead and get started. So this right here is a closed circuit, right? So this is a battery, right? Battery is a source of energy. It provides energy, okay? So this battery right here, and this is like a copper wire around it. One end of the copper wire connects to negative terminal, and the other end of the copper wire connects to the positive terminal, okay? And then in between flows the current. Okay, so right here there is a stream of electrons or a flow of electrons which is leaving negative terminal and going to positive terminal. So that's a closed circuit, all right? Now let's look at, if you have a microscope, right? And you put the microscope on this copper wire, you will see something like this. These are basically, the one in green are negative charges, or you can call them electrons, and the one in red are positive charges, okay? So atom basically has a negative charge, a positive charge, all right? So that's what basically, we have a series of positive charges, a series of negative charges, okay? And keep in mind that these are held loosely, okay? So negative charge and positive charge are held loosely in an atom, and we take advantage of that. So if you look in here, this negative charge right here is going to push right here, okay? Then this negative charge is going to push right here. This negative charge is going to push right here. This negative charge is going to push right here. This negative charge is going to push. So that's flow of electrons, okay? So basically, if I have to define current is flow of electrons, okay? So that is the classic definition. Flow of electrons, it's a stream of electrons, going in a certain direction. Now, here's the thing. As I told you, current leaves negative and goes towards positive, just like I'm showing right here, okay? So now what we have to do is we have to just deviate from the reality a little bit to make our life simple. So it's mathematical convenience, and I'm going to show you why. So, as these negative leave and travel at speed of light, okay, in a wire, these positive right here, the positive charge right here is basically left with a hole, okay? So the only thing in the atom now is just the positive charge. So it's left with a hole. Same thing for this. When this negative leaves, this positive charge is left with a hole. So for mathematical convenience, what we do is that we in equations and when we are solving problems, for the sake of mathematical convenience, we say the current is flowing in this direction, from positive to negative, okay? Right here, positive to negative. So this is for mathematical convenience, because if you solve the equations and you put negative, negative, negative everywhere, because that's the real direction, you can solve problems with that also, with this right here also. However, you're going to have too many negatives. So just to make life easy, what we are doing is that we are saying electric current travels from positive to negative, but in reality it does not. But this is just a mathematical convenience. All right, so just wanted to go over that. So when this electron leaves the atom, you're left just with the positive charge. Okay, now that is called as hole current, because there is a hole, right? When the negative leaves the atom, there is a hole. So that's why we call this hole current right here, and we show the direction right here, whereas we show the direction for flow of electrons this way. So I hope this makes sense. I know it's a sort of like a deviation, but we're doing it for the convenience to solve the problems. And you will see, once we progress and we dive into circuit analysis and try solving equations, you will see what I'm talking about. Okay, now let's see what is the unit of, I'm going to erase that because we're going to stick with this. What is the unit of current? Unit of current is amperes. Okay, amperes. Okay, so when you say it's amperes, what would be the unit of voltage? Unit of voltage. Unit of voltage is V. Okay, so I'll explain you in just a minute what the voltage is. So let's say, I'll give you an example. You take a straw, like a really, really narrow straw, the one you get at Starbucks just to stir your coffee. If you take that and if you blow, right, if you blow that straw, the air coming out of that would be an example of electrons flowing, current flowing. And the push, which you are blowing, that push is voltage. So voltage is nothing but potential difference. It's like a pressure, a push to move the current along. Hope that makes sense. So that's what the voltage is. Let's see what else. So we are going to talk about what a resistance is. Resistance. Resistance is basically, if you have current flowing in this direction, and this is a copper wire, now there are going to be line losses. When the current moves along this, okay, there are some line losses, some sort of resistance, some sort of friction. So if you're sending, like, I don't know, maybe 10 ampere current, you might not receive 10 ampere over here. You might receive 9 amperes over here. So those are line losses. In other words, this copper wire has provided some resistance. So there are some other conductors also, like silver. I think silver is good, but mostly in today's world, we use copper. Okay, let's go over some units. So you have, let's say for amperes, the unit is ampere. You can do milliamperes, okay? You can do microamperes. That's 10 to the minus 3. This is 10 to the minus 6. Then you can do resistance. The unit is ohm, okay? And